Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, mathematics, then please do subscribe to my channel. So in my previous videos, I was actually discussing the matters in our surroundings, how matters are made of particles, and I also discussed what are all the characteristics of particles, and I also discussed the states of matter. Solid state, liquid state and gaseous state. All these three states of matter were discussed in previous videos. So in this video, we will be learning how matter changes its different states. So can really matter change its state? So matter can be solid. In solid, particles are tightly bound with each other. In liquids, particles will be loosely bound with each other. In gaseous state, particles will be very loosely bounded with each other and they can freely move around the atmosphere. So now can a matter can be converted from a solid state to a liquid state or from a liquid state to a gaseous state or vice versa. So the process of conversion of this particular matter into different states. So what are all the processes are there? We will be going on discussing in this particular video. So when you actually supply heat to this particular solid state matter, so at that particular time, you are actually supplying energy to those particles. So heating means you are actually heating a particular solid matter. So while heating that solid matter, let's say you have a beaker like this and you have put some ice cubes in this particular beaker. So and you are heating this particular beaker. That means you are actually supplying heat energy to those particular ice cubes. So that particular ice cubes, the particles which are there inside that particular ice cubes will be tightly bound, but when you actually supply energy to those particles, the kinetic energy of the particles increases. So when the energy is actually supplied to these particles, then the tight bonding which was there between particles in that particular matter, that particular energy will break this particular bondings which are there in between particles inside a matter. And then these particles will actually get the random motion through which they can easily move throughout the matter. So at that particular time, this particular solid will be converted into liquid. That means when you are actually supplying kinetic energy to this particular ice cubes, this ice cube will be converted into liquid state. That means ice will be converted to water. So ice cubes are actually converted into water when you actually supply a necessary amount of energy to this particular ice. So if you supply more energy to this particular water, even after ice getting converted to water, still if you are supplying energy to that particular water, so even in water, particles will be having light amount of bonding with each other. So that's why it is also bound to a certain boundaries. But when you actually supply more and more kinetic energy, particles, the bond which is there between the particles will get loosened up and they get breaked, and those particles will be free to escape out of that particular bound system. So at that particular time, this particular liquid or the water will be converted into gaseous state, and these gaseous molecules are free to move around the atmosphere. That means now they are not restricted to one particular boundary conditions. They are actually free to move around the atmosphere. That is because the bond which was holding those particles together has now broken because of supply of excessive kinetic energy to that particular particles. So like this, when you actually supply heat energy, you are actually increasing the temperature of that particular system. You are actually increasing the temperature of that matter. Because of that, you are actually increasing the internal kinetic energy of those particles which are there in the matter. Because of that increase in kinetic energy, bond between particles will be broken and that particular bonding will become weaker and weaker. So when it becomes much more weaker, it will become liquid, and when it becomes much more weaker and when those bonds get breaked, at that particular time these particles will be converted into gaseous state and those gaseous molecules can move around the atmosphere. This is how a solid will be converted into liquid and liquid will be converted into gaseous state. So now you can actually do an experiment. You can have certain amount of ice cubes inside a beaker and you can supply some amount of heat to this particular beaker. You can keep a particular thermometer into this ice cubes and you can actually measure the temperature on this particular thermometer. So when you actually supply heat to this particular ice cubes, this ice cubes will get converted into water. So in that process, there will be certain amount of heat which will be hidden inside the system. That means this particular ice cubes, suddenly they don't get converted into water immediately. So the little amount of this particular ice cube will go on melting. Unless and until entire ice cube melts down, the temperature in this particular thermometer will not rise. So when you actually supply certain amount of heat to this particular ice cubes, all these ice cubes should get melted. Unless and until all these ice cubes gets melted, the temperature in the thermometer will not rise. This actually shows entire ice cube should be melted to water, then only the temperature of thermometer will rise. That means some amount of heat is actually there in the surrounding of that particular ice cube. So let's say this particular ice cube was 1 kg, and when you actually supply heat to this particular 1 kg of ice cube, this particular ice cube will reduce to 0.5 kg and some amount of liquid will be there. That means 0.5 kg of ice has got converted into liquid, and still 0.5 kg of ice is there inside that particular water. So that means in a beaker you have a 1 kg of ice. Now in the same beaker you have 0.5 kg of ice and 0.5 kg of water. That means 1 kg of ice has converted into 0.5 kg of ice, that is solid, and 0.5 kg of liquid, that is water. So now this particular water will be having the extra heat which you are actually supplying continuously to this particular ice cube. That means temperature of ice cube remains the same, that is 0 degree Celsius, because at 0 degree Celsius this particular ice cube will be converted into liquid state. That means ice cubes will be converted into water. So at that particular 0 degree Celsius, even if you keep thermometer on this ice cube, even while this ice cube is melting, still it will be showing the same 0 degree Celsius. That means the extra amount of heat which you are actually supplying to this ice cube will be having in that particular beaker. That means the heat is actually there in the beaker, not in the ice cube. Unless and until that ice cube is completely converted into water, the temperature of ice cube remains the same. 1 kg of ice cube got converted to 0.5 kg and then it gets converted to 0.25 kg. Unless and until completely transform into liquid, the temperature of ice cube will be 0 degree Celsius. Then where did the extra heat is going which you are supplying to that ice cube? So that extra heat is actually going to the surrounding of that particular ice cube. That means the ice cube is utilizing the heat, but the temperature of ice cube is not increasing. That particular hidden heat is actually known as latent heat. This is one of the important concept which you should actually remember. The amount of heat which is there, which is actually hidden in that particular system while converting ice into a liquid or a solid into a liquid. So that particular hidden heat is actually known as latent heat. So where does that heat is actually hidden? It is actually hidden in the surrounding of that particular ice cube. That means this particular ice cube is getting the heat. Using that heat, the heat is actually making that ice cube to melt, and that particular heat is actually there in the liquid and the beaker which is there in that particular beaker. So that means the ice which is actually there, which is actually reducing in its size, which is actually reducing its amount, will be 0 degree Celsius until it is completely transformed into a liquid state. Even ice is actually receiving the heat, still the temperature of ice doesn't increase unless and until that ice is completely converted into water. That particular hidden heat which is actually there in the surrounding but which is not there inside ice. That means the temperature of ice is not increasing, but still the heat is actually absorbed by that ice. So that's why the heat is there but temperature is not rising. So that's why that particular heat is known as hidden heat, which is actually hidden. So that's why this particular hidden heat is known as latent heat. So there is one more concept related to this particular latent heat. So that is actually known as latent heat of fusion. So if you want to understand what is latent heat of fusion, then you should understand what is latent heat properly. So now I have given so much of explanation on latent heat. You can actually watch this video multiple times to understand what is latent heat. So when you actually understand latent heat, then only you can understand what is latent heat of fusion. So latent heat of fusion is that particular latent heat which is actually required. That means the hidden heat which is actually absorbed by that particular ice. So how much amount of heat you are actually supplying to convert 1 kg of solid into liquid. So there is 1 kg of ice or 1 kg of solid which you are actually converting into a liquid. So let's assume you are having 1 kg of solid. So 1 kg of solid is converting into liquid. So how much amount of heat this particular solid is actually absorbing to get converted into liquid? So that is actually the latent heat of fusion. So that much amount of heat is required to convert this 1 kg of solid completely into liquid. So completely it should get converted into liquid. So that means that much amount of heat which you are actually supplying to convert this 1 kg of solid into liquid completely. So that much amount of heat is actually known as latent heat of fusion. So understand latent heat properly and then you will easily understand what is latent heat of fusion. So in latent heat, the heat which is actually hidden, the heat which is actually absorbed by the ice, and that particular ice will get converted into liquid, but the temperature of ice remains the same unless and until that particular ice is completely converted into liquid. Unless and until that particular solid is completely converted into liquid, the temperature of the solid remains same, but still that particular solid will be absorbing heat. So that particular heat is actually hidden in the surrounding of that particular solid. So that particular heat is known as latent heat. So when you understand this properly, you will understand what is latent heat of fusion, that is converting 1 kg of solid completely into liquid, how much amount of heat you are actually using. So that much amount of heat energy which is required to convert 1 kg of solid into liquid will be known as latent heat of fusion. So now we have actually understood what is latent heat. Now I have actually explained while converting this particular solid into liquid, there is a particular latent heat which will be there in this particular solid. So when you convert this particular solid to liquid, you will actually have a particular temperature range at which that particular solid will be converted into liquid. So for example, if you have a ice, so this ice to get converted into water, the minimum temperature should be more than 0 degrees Celsius. So at 0 degrees Celsius, ice starts melting. So this particular 0 degrees Celsius is actually known as 273.15 Kelvin. So this degree Celsius can be converted into Kelvin as well. So 0 degrees Celsius means it is always 273.15 Kelvin. This you should actually remember. So this is actually the temperature at which ice will be converted into water. So that will act as the melting point of that particular substance, that is water. So melting point of this particular ice, MP means it refers melting point. So melting point of this particular water is 273.15 Kelvin. So if you maintain temperature slightly above 273.15 Kelvin, so this particular ice will be converted into water. Similarly, if you want to convert this particular water into a gaseous state, there is one more temperature limit. If you overcome that particular temperature limit, the water will be converted into gaseous state. That particular temperature is actually known as boiling point. So boiling point of water is 100 degrees Celsius. That is actually 373.15 Kelvin. So for 0 degrees Celsius, the temperature in Kelvin will be 273.15 Kelvin. Now if you add 100 degree for this particular 0 degree Celsius, add 100 degree Celsius for this 0 degree Celsius, so it will be 100 degree Celsius. Similarly, here also you should add by 100 units. So when you add this by 100 units, you will actually get 273.15 Kelvin plus 100, that will be 373.15 Kelvin. So this is how you should actually convert degree Celsius into Kelvin. So for 100 degrees Celsius, at 100 degrees Celsius temperature, water will be converted into gas. That is, liquid state will get converted into gaseous state. So 100 degrees Celsius is the boiling point of water. So if you take any other chemicals, if you take benzene or if you take any other chemicals like ethanol, so if you consider any other liquids, so every liquids has its own boiling point. So only at that particular boiling temperature, liquids will be converted into gaseous state only at their respective boiling point. Similarly, certain solids have melting point. Only when the solid reaches that particular melting point, it will be converted into liquid. So there is a latent heat which is actually hidden at the melting point, and there is also latent heat which is actually hidden at the boiling point. So when solid gets converted into liquid, when solid gets converted into liquid, there is a border line here that is actually melting point. At this particular melting point, solid gets converted into liquid. Unless and until this complete solid is getting converted into liquid, the temperature of that particular solid remains the same. That is this particular melting point. So that particular extra heat which is actually hidden is known as latent heat at that particular point. Similarly, when you actually convert this particular liquid into gas, there should be a certain temperature which should be greater than boiling point. When you actually supply heat energy which is more than the boiling point of this particular liquid, that particular liquid will be converted into gaseous state. So this particular temperature at which liquid gets converted to gas is actually known as boiling point, and at this particular point the temperature of this particular liquid will remain the same as boiling point unless and until that complete liquid is converted into gaseous state. This also you can do with an experiment. You can take water in a particular beaker and you can actually heat this particular water and keep a thermometer inside this water and observe what will be the temperature. So when the temperature reaches 100 degrees Celsius on thermometer, at that particular point water will start boiling and it will get converted into gaseous state. So at that particular point, the temperature on thermometer will be 100 degrees Celsius only. It will not increase beyond 100 degrees Celsius. Even if you are supplying more and more heat which is actually having temperature more than 100 degrees Celsius, still the temperature of water will be 100 degrees Celsius unless and until the complete water is getting converted into gaseous state. So only when complete water is converted into gaseous state, then the temperature of that gaseous molecule will be more. That means the extra heat is actually transferred to the beaker and the gaseous molecule. So the temperature of liquid remains same 100 degrees Celsius unless and until that complete liquid is converted into gaseous state. So similarly, when you are actually heating a particular ice cube, so when you actually heat a particular ice cube, unless and until this complete ice cube is converted into liquid, the temperature of ice cube remains 0 degrees Celsius. That is, the temperature of this particular ice cube remains at the melting point. Similarly, unless and until this complete water gets converted into gaseous state, the temperature of water will be at boiling point itself. Even if you supply more heat also, the temperature of water will be remaining at boiling point itself unless and until that complete water is converted into gaseous state. So that there also you have latent heat, and here also at melting point also you have a particular latent heat, and at boiling point also you are having a particular latent heat. So this latent heat acts at this particular boiling point level, and latent heat will also act its role at melting point. So now you have understood latent heat at melting point, and you also understood latent heat at boiling point. To convert this particular 1 kg of solid into liquid, you are supplying certain amount of heat energy. So that particular heat energy is actually known as latent heat of fusion, which I have already discussed. Now the liquid which you are actually taking, the 1 kg of liquid which you are considering, should be completely converted into gaseous state. So how much amount of heat energy you are actually giving to 1 kg of liquid to completely convert that particular 1 kg of liquid into gaseous state? So that much amount of heat energy is actually known as latent heat of vaporization. So this is actually known as latent heat of vaporization. when you are converting solid into liquid, the amount of heat energy which you are actually using is known as latent heat of fusion. That means 1 kg of solid should be completely converted into liquid. Similarly, 1 kg of liquid should be converted completely into gaseous state. So the amount of heat energy which you are using was actually known as latent heat of vaporization. So you should not have any confusion between latent heat of fusion and latent heat of vaporization. So latent heat of fusion acts at melting point. Latent heat of vaporization acts at boiling point. That means at boiling point, at certain boiling point, how much amount of heat energy you are supplying to convert 1 kg of liquid into gaseous state, that much amount of heat energy is known as latent heat of vaporization. Similarly, at melting point, when you are converting solid into liquid, how much amount of heat energy you are supplying to convert 1 kg of solid completely into liquid, that much amount of heat energy is actually known as latent heat of fusion. So to have a better understanding of latent heat of fusion and latent heat of vaporization, you should actually go through this particular latent heat properly. So how pressure actually affects the particular change of state of a particular matter. So now if you take a particular gaseous state of a particular substance and if you apply pressure on this. So let's say you are taking carbon dioxide molecules and you are actually applying pressure on this particular carbon dioxide molecules. So when you apply more and more pressure to this particular molecules or the particles, these particles will come closer to each other and they will settle in a particular fashion. That means this particular particles are very close and they are actually forming bond with each other due to applied high pressure. So because of this pressure, this particular gas is actually converted into a solid object. That means this particular carbon dioxide gaseous molecules are converted into solid carbon dioxide molecule. So that is actually known as dry ice. So this particular solidified carbon dioxide. So solidified carbon dioxide is actually known as dry ice. So this particular solidified carbon dioxide can be obtained only under high pressures. Only when you put more and more pressure, then only these particles or the carbon dioxide particles will come closer to each other and they can form a solid state. Even the LPG cylinders which you are actually using in your homes, so there also they are applying certain amount of pressure in the cylinder so that gaseous molecule will remain in the form of liquid. So only when that pressure is released, that liquid will be converted back to gas. So only when it is at certain amount of pressure, that particular petroleum gas will remain as liquid. So that's why it is known as liquid petroleum gas. As soon as you open the knob of that particular cylinder, the liquid will be converted into gas and it comes out. So that means when you reduce the pressure, you are actually converting liquid into gas. Only when there is a certain amount of pressure, then only that particular petroleum gas can be stored as liquid, and even this carbon dioxide molecules can be stored as solid only under high pressures. Suddenly if the pressure is released, then again this particular dry ice or the solidified carbon dioxide will be converted back into carbon dioxide gaseous particles. So that means pressure also plays a major role in changing the state of a particular matter. There is one more activity which you can actually do. Take a china dish or a porcelain dish and keep some amount of camphor on this particular porcelain dish. So now put some fire on this particular camphor. So cover this burning camphor with a inverted conical flask. So this is actually a conical flask which you are actually keeping it inverted on a burning camphor, and cover this particular conical flask other end with cotton so that the gaseous molecule will not escape. So you can clearly see when you actually supply heat energy to this particular camphor, that means you are actually putting fire to that particular camphor. If you are putting fire onto that camphor, that means you are actually supplying necessary amount of heat energy to that particular camphor. So by using that particular heat energy, camphor will start burning and suddenly solids will be converted directly into gaseous state without transforming to liquid state. In case of water, the ice will be first converted into water, then it will be converted into gaseous state. That means certain solids will get converted to liquid and then they will get converted to gaseous state. But certain amount of solids like camphor will directly get converted into gaseous state. So this particular process where solid is directly getting converted into gaseous state is actually known as sublimation. So you should actually remember this particular term also. This is actually known as sublimation, where you are actually directly converting solid into gaseous state. So a particular matter is directly getting converted from solid state to gaseous state. So this is actually known as sublimation. So because you are actually blocking this particular gaseous molecule to go out of this particular conical flask, so that's why this gaseous molecule will be back converted into solid, and there will be slight amount of deposition on this particular conical flask like this. So the slight amount of deposition of this camphor which has got converted into gaseous state, because you have put cotton on the top, pressure gets increased. When pressure gets increased inside conical flask, the gas will be back converted into solid. So this particular conversion of gas into solid, that is the gaseous particles of that particular camphor is converting back to solid. That means here some amount of deposition is actually happening on this particular conical flask layer. So this particular conversion of gaseous state matter into solid state matter is actually known as deposition. So here, because of this particular cotton, there is a certain amount of pressure, because all the camphor is getting converted into gaseous state, and gaseous molecules inside that particular conical flask is increasing, and you are not allowing that particular gaseous molecules to go out because you have covered with a thick cotton. So because of that increased pressure inside conical flask, all these particular gaseous particles will be converted back to solid, and you can see a clear deposition on that particular conical flask surface. So because here gas is converting into solid and depositing on the conical flask surface, it is actually known as deposition. So conversion of gas to directly into solid will be known as deposition. Conversion of solid to gas will be known as sublimation. When you actually increase the pressure of this particular gas and when you reduce the temperature, gas can be converted into liquid. So you can see there are so many clouds formed in our atmosphere. So when these water molecules which are there in the ocean, they get evaporated because of heat energy which is given by sun. This evaporated gaseous particles of water, when it goes into the atmosphere higher and higher, temperature reduces. Because there is temperature reduction, these gaseous molecules will come back together and there will be a cloud formation. You might be thinking the water is actually evaporating in a gaseous form from earth and it is coming in the liquid form from the clouds. How is it possible? Because of condensation, gas is actually getting converted into liquid in the atmosphere. So that particular liquid or that particular water which has got converted into liquid is falling on this earth in the form of rain. So now conversion of this particular liquid into solid will be known as solidification. So conversion of liquid state into gaseous state will be known as vaporization, and conversion of solid state directly into gaseous state is known as sublimation. Solid to gaseous state is sublimation. Gaseous state to solid is actually deposition. Gas to liquid is condensation. Liquid to solid is solidification. Liquid to gas is vaporization. So all these terminologies you should actually remember. So there is one more concept in this particular chapter which is actually known as evaporation. So what do you mean by evaporation? So when you actually supply a necessary amount of kinetic energy to liquid, they get converted into gaseous state. So that particular process of conversion of liquid into gaseous state is actually known as evaporation. So there are three different factors which actually affect this particular evaporation. So one particular factor is surface area, because evaporation is actually a phenomena which happens on the surface of a particular liquid. So let's say you have a liquid like this. So you have a liquid in a particular beaker or in a particular container. So this particular change in state of matter, that is change from liquid state to gaseous state, happens at the surface level, because particles which are there inside this particular liquid cannot get evaporated easily because they are surrounded by other particles. But particles which are at the surface level of that particular liquid can easily break their bond and can escape into the atmosphere as a gaseous molecule. So that's why evaporation is actually a surface phenomena. Hence, increasing surface area will enhance the rate of evaporation. That means, for example, if you have a cloth, let's say this is the cloth. So if you have a cloth like this, you can wet that particular cloth, you can dip this particular cloth in water, and then you can fold that particular cloth and you can keep it for some 8 or 10 hours. And then you can open that particular cloth. That cloth will not be dried because you have decreased the surface of that particular cloth. Now, if you take the same cloth and if you increase the surface area of that cloth and then you keep for drying, at that particular time, even in lesser time, the cloth will get dried. That means the water molecules which was absorbed by that particular cloth will be evaporated very easily because of increase in surface area. This is one example which you can actually have to understand how surface area matters in rate of evaporation. Rate of evaporation means how much time it takes to evaporate complete liquid molecules which are there in that particular container or in that particular object. So the another factor which is responsible for evaporation is humidity. Humidity also plays a major role in rate of evaporation. If the atmosphere is having more humidity, then already there will be water molecules in the atmosphere. What do you mean by humidity? Already in the atmosphere, if there is too many water molecules, that means the humidity of atmosphere is too much. At that particular time, rate of evaporation decreases. So another factor which actually affects this particular evaporation is wind flow. When there is huge wind flow, at that particular time, your clothes get dried very much faster, because when wind is actually blown in a higher speed, the water molecules which are there in the atmosphere will get blown away and there will be some kind of decrease in humidity. Because of that, water molecules which are there in this particular cloth, which are actually kept in that particular wind flow, will be easily dried. Because of the reduction in the water molecules which are there around that particular cloth has reduced because of the flow in wind. So due to this particular wind flow, there is reduction in water molecules around that particular cloth, and that cloth can get dried very easily in a higher rate. So rate of evaporation actually depends on how fast the wind is blowing, how much humidity is there around that particular liquid, and also how much surface area is actually there in that particular liquid. You can do one more experiment. If you take 1 liter of water in this kind of container, and if you take 1 liter of water in this particular container, so the 1 liter water which is there in this container, that is in container A, let's say this is container A and this is container B. So the water in container A takes lot of time to evaporate this complete 1 liter water. Supply same amount of heat energy for both the containers. Even after supplying same amount of heat energy to 1 liter of water in container A and to 1 liter of water in container B, container B water will get evaporated faster because of increase in surface area. So if you are keeping in a bigger container, if you are keeping water in a bigger container, and if you are keeping water in a smaller container, and if you are keeping same amount of water, and if you are supplying same amount of heat energy, a bigger container water, the same amount of water which is there in bigger container will get evaporated very faster because surface area is increased. So this also proves that surface area is actually important for rate of evaporation. That means how much fast evaporation will be happening. So that is in how much time evaporation happens. That is actually the rate of evaporation, and that rate of evaporation increases with increase in surface area, decreases with increase in humidity. The rate of evaporation increases with increase in wind flow. So all these three factors you should actually remember how evaporation of a particular liquid is affected. So this is all there in this particular video. Like this, I will be uploading more physics, chemistry and mathematics videos in this particular YouTube channel. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.